How many zeros are there at the end of 2021 factorial? Okay, this is actually kind of like a standard question for contest mathematics or interview type questions applications. So in any given number, if it ends in a certain number of zeros, all of those zeros come from multiples of 10 in the factorization of the number. So what we need to do is, if we wrote out, if we want to see how many times we can factor the number 10 out of this, and that will be equal to the number of zeros at the end of this number. Another way of doing that is to realize that, of course, every factor of 10 comes from a pair that has to be a 2 and a 5. The only way to get a factor of 10 here is to match up pairs of 2s and 5s. And of course, when we have something like, when we have something expressed as a factorial, when you count upwards, like 1 times 2 times 3 times 4 times 5 times 6 and so on, you're going to pass multiples of 2 more often than you're going to pass multiples of 5. And so you don't really need to count the number of pairs of 2s and 5s. You only need to count the 5s. The other thing we have to be careful about is multiples of 25 and 125. So powers of 5 we also need to be careful about because we need to double count those. So essentially what we need to do here is, as we multiply the numbers 1 times 2 times 3 times 4 times 5, okay, I'll write it up to 10, and then I'll just go dot, 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 times 24, times 25, times 26, dot, 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 and so on. We want to pick out the multiples of 5. So this gives us one multiple of 5. That gives us a multiple of 5. This gives us 2 multiples of 5. And the number 50 also gives us 2 multiples of 5. So first, let's count how many multiples of 5 there are. Well, that's just going to be, the 2021, of course, does not have any multiples of 5s. But 2020, the number of, if we count the numbers from 1 up to 2020, the number of times we hit a multiple of 5 is going to be 2020 divided by 5, which is, oh lordy, 404. Yeah, okay. So we pass, in going across like this all the way up to 2021, we pass 404 multiples of 5. Now let's count how many multiples of 25 there are. Well, there's obviously no multiples of 25 between 2001 and 2021. So now we need 2000 divided by 25, which is four. Is it 80? 80 times 25 is equal to 4 times 20 times 25, which is 20 times 100, which is 2000. Yeah, okay. So we have 404 multiples of 5. 80 multiples of 25. What's the next power of 5? 125. Okay. This should be approximately well, what's 125 times 20? This is 2,000 plus 25 times 20. That's too big. 125 times well, let's go like this. 125 times 10 is 1250. And then 125 times 5 is 625. And if we add these together, 5, 7, 8, 1. Oh, so 125 times 16 is equal to 2,000. Is that right? Yeah. Okay, so we have 2,000 divided by 125 is equal to 16. And of course, there's not going to be another multiple of 125 between 2000 and 2021. Okay, and what's the next power 5? 625, right? This one should be easier to figure out. Is it 3? 625 times 3. $18.75, yeah. So if we add one more of 625, it'll be quite a bit larger than 2021. So there are 3 multiples of 625. I'll just put a 3 here, divided by 625. I guess we could even say 2021 is equal to 3 plus some remainder over 625, where r is less than 625. Okay, so if we add these numbers up that I've underlined, 404 plus 80 plus 16 plus 3, that should give us our answer. 404, 80, 16, and 3. Okay, so I get that there are 503 zeros at the end of 2021 factorial. Let me make sure I did this addition correctly. 10, 13, 10, 5. Okay. Yeah, I mean, maybe I made some arithmetic mistakes somewhere. You could check this a little bit more carefully, but the procedure is correct. So let me sort of just reiterate what I've done. Write out all the numbers from 1 to 2021. You want to count all the multiples of 5. That's what we did here. And then you want to count all the multiples of 25. That's what we did here. Count all the multiples of 125 and of 625 and so on. You want to count the number of times that each multiple of a power of 5 is picked up, because each multiple of 5 will contribute a 5, but you need to double count the multiples of 25 because they have another 5 in them. You need to triple count the multiples of 125, and you need to quadruple count the multiples of 625. So we're counting the multiples of 5 once. We are counting the multiples of 25 another time. We're counting the multiples of 125 yet another time, and so on. So as long as I did all the divisions and multiplications correctly, and I did this addition correctly, the answer I get is 503. Yeah, this is a pretty standard problem. I've seen versions of this problem which are made a little bit more difficult by doing things like, you know, how many zeros does this factorial number end with when it's written in base other than 10? And so then you just need to understand, you know, in a different base, how do I end up getting zeros at the end of the number? So for example, if you're in base 9, then you end up with zeros at the end of the number anytime there's a factor of 9. But how do you get factors of 9? You need to count factors of 3s and the number of ways you can pair up a 3 and a 3. So that can be a little bit more complicated, because here the factors of the zeros come from factors of 10, and 10 can only be constructed by pairs of 2s and 5s. But of course, you're going to have more than enough 2s to go around, and so you only need to count the 5s. But if you're doing it in a different base, like base 9, you know, that's a single 3, but a single 3 on its own doesn't give you what you want. You need to count pairs of things that give you a 3. But then, of course, you know, things that are a multiple of 9 give you the pairs automatically in some sense. So it's a little bit more complicated than this, but the sort of underlying principle is the same, where you're looking for, you're counting multiples of the building blocks of the zeros. So nice little problem. You know, I've seen this type of problem many times in the past, and once you know what to look for, it's pretty straightforward to get started. Thanks for watching.